Okay, so welcome back. Today we're going to be um, learning how to graph the other three. We're going to start the process of learning the other three, how to graph the other three trig functions. So that's secant, cosecant, cotangent. Today we'll focus on just cosecant and how to graph its trig graph. Okay. Now, what's really nice, if you kind of reviewing, right? You have sine of x and its inverse. Um, its inverse is cosecant, right? And then you have cosine of x and its inverse is secant x, and then you have tangent x and its inverse, which is cotangent, right? So today we will focus on just sine or the cosecant wave and how it relates to the sine wave. Okay. Now to graph cosecant, you actually will graph a sine wave, and then you'll cut it. You'll cut the graph, imaginarily cut the graph at certain points and either flip up or flip down, depending on where that graph is at. Okay, so this lesson will be a really good review of the sine wave and how to graph that. We'll just do it very lightly, and then we'll flip the graph to get the cosecant, the graph. Okay, so everything, just like in my other videos, everything is still the same as far as for sine. So your A is out in front. So your A is amplitude. Well, you already know that. A is amplitude, and so our amplitude for this graph is 2. And all right, so A is 2, right? Our period length for sine is always 2 pi, right? And it's 2 pi divided by our B value, which in this case our B value is 1. So the period length for y equals 2 cosecant of x, right, is 2 pi, right? Now, like I said before, basically 2 cosecant of x, what we're going to do is we're going to graph y equals 2 sine of x, and then we'll cut the graph at certain points, and that will give us our cosecant graph. All right, so this still relates to this, and this still, is still the amplitude and period length for 2 sine of x, right? So just like reviewing the 5 points to find for sine, right? So you're going to take 2 pi and divide it by 4, right? 2 divided by 4 is 1/2. That's pi over 2. So each of my 5 points, remember for sine, we always have those 5 points. So 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? There's no phase shift. We're not shifting anything. So these 5 points are what we'll use. Okay, so we'll come to our graph. Okay, we'll plot those 5 points. There's 0. Here's pi over 2. Here's pi. Here's 3 pi over 2. And here's 2 pi, right? Now I will graph y equals 2 sine of x, okay, in black, and then I'll switch colors, and then I'll show you what the actual graph of 2 cosecant of x when we cut in a different color here in a second. So just kind of reviewing, right? Our amplitude is 2, right? And so we're going to go up 2 and down 2. Now, 2 sine of x, there's no phase shift or anything like that. So we start at the origin. Okay, the next point we go up because our amplitude's positive. At pi over 2, we're back at the x-axis. At 3 pi over 2, we're down here at the negative amplitude, and then we're back, right? So this is our sine wave of y equals 2 sine of x. Now, to graph 2 cosecant of x, I'll do it in blue. All right, and what you do is you will draw a vertical asymptote through every point where your graph crosses the x-axis. Okay, so here, crosses here, here, and here. Let me redo this because it looks like it's crooked. Alright, now, at each of these points where you have these dashed blue lines, okay, I'm going to imaginarily cut my graph, okay? And when I cut my graph, I'm going to, for this section right here, okay, I'm going to cut my graph here and here. And when I do, I'm going to flip this part of the graph up, okay? And my maximum point right here on this sine wave now becomes my minimum, okay? And at the same point from here to here, I will cut the graph and I flip down. Okay, so my minimum now becomes my maximum. Okay, and the blue part of your graph is the graph. So the blue part is the graph of y equals 2 cosecant of x. And that's all you have to do. Okay. Now, what if they start messing with a b value? All right. So you have another one. Y equals 1/2 cosecant of x over 3. Okay. So I'm going to first graph. If I change this to its inverse, first, so it looks like in sine, it'll look like this. Y equals 1/2 sine of x over 3. So I'm going to first graph this, cut my graph, and then flip each part up or down depending on where it's at. Okay, so my amplitude for my sine wave, my amplitude is 1/2. Okay, my period length, I'm going to take 2 pi, and I'm going to divide it by, in this case, 1/3. Alright, so 2 pi divided by 1/3 is 6 pi. Alright, now to get my 5 points, I'm going to have to take 6 pi divided by 4, so that's 3 pi over 2. So each mark I'm going up 1.5. Alright, so instead of writing them out like I did in the prior one, I'll just write them across this, the x-axis. So I have 0, that's my first point, and then I have 3 pi over 2, that's 1/2, and then 1/2 plus 1/2 is 3, that's 3 pi, and then I have 4.5 pi, which 4.5 pi is 9/2 pi. You can think of this as 3 pi over 2, 3 pi is 6 pi over 2, and then 9 pi over 2, and then 12 pi over 2, which is 6 pi. Okay? Now, our amplitude is 1/2, right? So if this is 1 and this is 1, so I start at 0, right? At 3 pi over 2, I'm only going to come up halfway because my amplitude is 1/2, and then at 3 pi, I'm back at 0. At 9 pi over 2, I'm right here. And then at 6 pi, I'm back here. So if I connect, my graph is really, really shallow. All right? And I'll do the y equals 2 cosecant of x over 3 in blue again, right? So every time, everywhere where my graph crosses the x-axis, I will draw a vertical asymptote, okay? And at these points, remember, I'm cutting, I'm going to imaginarily cut my graph, okay? And so then at this maximum point, at 3 pi over 2, instead of it being a maximum, now it's going to be a minimum, okay? And then instead of at 9 pi over 2, instead of this being a minimum, now it's going to be a maximum. So again, the blue lines are the graph y equals 1/2 cosecant of x. Okay, so there you go. Hopefully this helps make some sense into how to graph the cosecant function with different varying amplitudes and period lengths.